Alright, welcome to our second video tutorial on Python programming. My name still remains Jonah Juzie, and this is ISU Group Training Enterprise. So in the previous video that we produced, we mentioned that Python is a dynamic, wonderful, high-level programming language that first of all does not need any form of translation into computer understandable codes, because it already has an interpreter that makes the code machine or produces the code in a way that the machine or the computer already understands. I don't know how best to put that, but let's just leave it at that. Now, first off, Python is a dynamic programming language. It's not a static programming language. Now, for those of you out there who are familiar with Java, you know that in a Java application, in order for you to declare any variable, you first of all need to declare the variable type. So if, for instance, I wanted to put a value such as string, I would need to type the type of variable that it's going to be. So for instance, I would have something like string variable is equals to hello. Okay, this is a typical Java way of declaring a variable. Okay, but with Python you don't need to do this. Python automatically identifies the object class, the object where a particular variable in which you type in, where it will belong. So all I have to do is, if I wanted to type or specify a string variable, all I have to do is just say variable is equals to hello. Hello. In which case, what I mean there is that a variable known as var will have the value of hello. So Python already automatically knows that var will be a string because this value is already a string. So it will create a string memory in its a string variable in its memory and allocate the value of hello. So that is what I mean by Python being a dynamic programming language. It does not need for you to declare variables first before the values could be assigned to the variables. It automatically knows the variable type, the objects in which they inherit from, and the properties in which it will come along with. So that's usually very helpful because it makes it easy for us to just write variables and then not need to initially have to declare them. So that reduces some of the codes that we would probably need to write in Python as opposed to a programming language like Java. So Python is very much dynamic in the way it assigns values to variables, unlike Java that is very much static. Now, we also mentioned something about Python being coming with an interactive how would I put it, command line that makes it easy for you to interact with the interpreter. What does that mean exactly? It means that by the time you launch this Python command line, you are interacting directly with the Python interpreter. Okay, so there are two ways in which Python codes or Python scripts are usually executed. One of them is either you come to the Python interpreter here and you directly key in your codes or your scripts and then you run them by hitting the enter button. For example, if I were to say 1 plus 3, I got my result, which is 4, because I'm interacting directly with the Python interpreter. The Python interpreter is what is resolving this mathematical equation and giving me the answer directly. But another way we can do this is also we can create a Python file and then of course save all our scripts or all our codes in that file and then launch it up. By that, this is what I mean. If I go to my PyCharm projects, and this is my project folder, these are all the Python files in my folder. And take note, for you to identify a Python file, it has to end with a .py, that is a .py. This is what helps you know that a particular file is a Python file. So you can create a script in Python. For example, this is the script that I'm creating, and I call it new class.py. Okay, let's say I do something like request for something like this. Hello there. So if I were to create this particular Python script and then save it in whatever location that I need to, so I can now call it up and then execute it through the interpreter. So in this case, if I were to right click and then click on run new class, what the IDE does is the IDE sends this file to the interpreter, and the interpreter runs this file and produces the result as you're seeing here on the output display. If I want to do the same thing but with the command prompt, all I have to do is bring up my command prompt, which is different from the Python command line. So this is the normal command prompt that we all have in our systems. So all I have to do is change the location of the directory to the location where you have your Python projects or Python files hosted. So all I have to do is change directory. For most of you who are familiar with the command prompt codes, you know already that. Now this is the directory location where all my Python files are located. So I'll just copy the path from there and then paste it here on the command prompt and then hit the enter button. So the command prompt now is pointing to that particular directory on my system where I have all my Python files installed. So all I have to do now is call the Python interpreter and then tell it to execute a particular file known as new class.py. Hit the enter button and you see the command prompt is trying to call up the Python printer, which will now try to run this particular class, this Python script, new class.py, in order to give us the result. So the result is what is currently processing, and once it's done processing, it will print the answer here. Okay, a couple of things that we did here. It's what is giving it some of the errors that you're seeing. Let's change a few things to allow it to behave well, at least for the sake of our classes for today. So let me change that and change that. Just a simple code that would help it run appropriately well. So, and then I'm going to highlight something very important as this code runs that will help you appreciate the different methods of calling up a Python, running a Python script, and some of the drawbacks, the pros and cons of doing that. Good. Now you notice that this is the outputs of running these Python script from the command prompt. Okay, I'm trying to run it from the command prompt, and hence the result is going to be displayed here on the command prompt. But you notice that here is giving me a syntax error. It's missing a parenthesis to call print. Did you mean print right justify question mark? So there is a bit of an issue here that the Python script needs to rectify, running it from the command prompt here. But you notice that running it here on the IDE, running this same class on the IDE here, there wasn't any problem. Everything went smoothly and fine. Now also try that with the Python command line. If I run this particular line of code, which is on the script that I'm calling with the command prompt, if I run this particular line of code here, print write justify, you see the interpreter runs this code successfully without any hindrance. So the question now is, what is causing the problem that the command prompt here is flagging? Okay, now you notice that for the command line here, the Python command line here, as well as this PyCharm IDE, both of them are interacting directly with the Python interpreter, which is quite unlike the command prompt here that is referring or calling up the Python interpreter and then trying to use the interpreter to run this class. So there are some bugs that this guy would find it difficult to navigate through and may likely flag errors. So if I want to rectify that, all I have to do is put those braces that it's requesting for, and if I run the application again, you'll see it will run perfectly well. So that's one of the drawbacks about running programs from the command prompts. There's usually bound to be some minor, because command prompt is not interacting directly with the interpreter, whereas it's trying to just call it up. So you can see it now perfectly runs it very well because I've added braces. Most programming languages like Java, they would require braces like this before you run a particular code. But with Python, it is not a must for you to put these braces in order for you to print a particular string. But if you want to put it based on your use of other programming languages and you're being used to it, you can feel free to go ahead and do it. there isn't any problem. So for instance, if I run this application, you'd see it will print the output just fine and there is no problem. So feel free to add a parenthesis if you want to, but if you don't want to, you might as well feel free to remove them out as well. Again, the same thing applies with the semicolon. Python does not really require a semicolon for you to end a particular line of statement. By default, once it gets to the last character along that line, Python knows that's the end of the statement. Okay, but if you still want to, you can put the semicolon there, and there's not going to be any problem. It will understand and use it just fine. So now let's go into some of the main things that we are going to do in the course of using Python. Some of the things that we need to be familiar with in the course of our use of Python to run programming scripts or programming codes. Now let's start with comments, writing comments in Python. Okay, with Python, if you want to make a comment, all you have to do is use the pound symbol, and anything that you write would be a comment. Okay, that's a single line comment, whereas in programming languages like Java, it's usually a double quote like this, but for this, it's the pound sign. But for the multi-line comments, if you want to make a comment that you want it to cut across different lines, you have to use single quotes into 3 places. Okay, so you can see these are 3 single quotes, and then everything that you say under those will be viewed as comments. Now, also moving over to strings, Python has 2 different methods it uses to identify a string. That is the double quotes as well as the single quotes. Okay, so with Python, these 2 are used to represent strings. Anything that comes in between those 2 characters will be viewed as a string. So if I print this and print this and then run this code, these are 2 separate lines of codes, and Python understands that these 2 are all strings. However, it's very important that whichever one you stick to in a particular script, you try as much as possible to remain with that one, just for neatness purposes. But there are few instances where you would have to pick one form of one of these over the other. If, for instance, I wanted to make a statement like I can't come home, you say in this instance I need to use the single quotes as part of a word in Python. Hence, I'm using double quotes. So if I run this, it works just fine. If I were to use single quotes, then there would be an error, because at this point in time, with the first single quote that comes in here, first pair of single quotes that comes in here, Python assumes that you're using this to end the string, and as such, the rest would be an error. So here becomes a problem now. So in this instance, if you know you're going to need single quotes as part of a word in your string, then it's better off you use the double quotes to commence your string. But if you still want to continue with the single quotes, then it definitely means that you're going to have to put an escape character, which is this slash button there, and then put this as a single quote, and all will still be fine. There's also an instances such as, and you can see that's where this guy comes out. There are also instances such as in use of regular expressions, which we'll look into as we advance in Python project. Such instances as well require your careful use of this instead of this to declare a string, because this makes up part of a pattern that you're going to be searching for. We'll highlight that once we get to regular expressions. So this makes it possible now for you to be able to run your program, and your program works just fine. That is the standard string representation in Python. Now, going back to mathematical computations in Python, Python has a particular sequence of priority that it gives to equations that need to be resolved mathematically. For those of us who are in school, remember what we used to learn we learned something about BODMAS, okay, and that was the sequence in which mathematical uh, um, equations are given priority. So you first of all start with the brackets, then multiplication, which is off, then division, multiplication again, addition and subtraction. Well, for Python uses a system known as PEMDAS. Yeah, PEMDAS. P stands for the parentheses, which in this case are this. E stands for exponential, okay. M stands for multiplication. D stands for division, addition, and subtraction. So that is the order of priority in which Python follows in executing or resolving a mathematical equation, so that you know when you're trying to use Python to resolve a mathematical equation, when you have a whole lot of equation that carries a whole lot of mathematical operators, you have addition, multiplication, division, you now have an idea as to how Python will go about resolving that mathematical equation to give you the answer. Alright, now by default, when we type this word print, Python sends what we're trying to print to the standard output, which is the screen here. Print here is simply a way of telling the Python IDE or the Python interpreter that whatever you're trying to print should be sent to the standard output, which is the screen here. That's for the IDE. For the idle GUI that comes with the Python interpreter, this is also the Python screen. Okay, so anything you're trying to print will be displayed here. Likewise, for the Python command line, this is also the screen for it. So anything you try to print will also be displayed here. But alternatively, in the course of wanting to perform complex applications or write complex applications, you might want to redirect your output to some other location. You might want to send it out to a file, you might want to send it out to a printer, and many other different output sources. So we're going to look into each and every one of those when we reach that stage in our Python tutorials. Now, lastly, before I conclude this video for today, I also want to make mention of something very important, which has to do with the standard input for Python. We just mentioned that print is a standard input that sends whatever you want to output to the standard output, being the screen on the Python project or Python whatever on Python interpreter. So whenever you use print, by default, Python sends the output to the screen. Now for the input as well, for inputs, and it comes simply as that. This represents the inputs from your keyboard. So we say, please enter your name. So assuming we do this, so once we request for an input like this, Python will know that this is a standard input, which will definitely have to come from your keyboard. So anything that comes in from here will be associated with the keyboard. So if we run this application now, when it reaches this place, Python will request for an input. So I can put my name is whatever you put. But take note that there are two different forms of these inputs. There is the input that requests for that you type some. Both inputs definitely request that you type something into your from your keyboard, but you have inputs and you also have raw inputs. Okay, same thing. Please state your name. And the difference between these two is that, as this implies, anything you type under this is taken as a string, whereas this will interpret or will resolve it to the particular object in which it is. So if I were to type, like in this case I typed 4728, this input knows that what I've typed in is an integer or a number. But if I were to run this and then I type me, M-E, or characters, input will know that what I've typed in are strings. If I were to run this and I type in decimal figures with decimal or some zeros, the Python script will automatically know that I'm inputting some decimal values, which by default is a float type of variable. So input automatically knows that what I'm writing in, it knows the particular object in which it belongs to. Likewise, whether it's a string, it's an integer, or a floating point number, Python will automatically detect that by default. Whereas for the raw inputs, whatever you type in after executing this code, Python will take that as a string. So be it numbers, be it characters, be it letters, whatever it is that you put in, Python will interpret this as a string. Now, in the next video that we're going to produce, I'm going to show you where this is very much important and where they come in handy and why it's vital to know which should be used at any point in time. So, I'm going to stop this video here. If you have any questions, like I said, if there's anything I've skipped, if there's anything you don't understand, feel free to hit me up, and then I'll produce another video that will explain everything thoroughly and would help you understand. Once again, this is Jonah. Thank you for watching our video, and look forward to enjoying more videos that will help you learn more about Python.